Chapter 14, Thermodynamics. 14.2, Thermodynamics Processes. Learning outcome. At the end of this chapter, students should be able to A. Define the following thermodynamics processes: isothermal process, isobaric process or isovolumetric process, Isobaric process, and Adiabatic process. B. Discuss PV graph for all the thermodynamics processes. 14.2 Thermodynamics processes. There are 4 specific kinds of thermodynamic processes. It is isothermal process, isobaric process, or also is called isovolumetric process, Isobaric process, and adiabatic process. (14.2a1) Isothermal process is defined as a process that occurs at constant temperature. In isothermal changes, when a gas expands or compresses isothermally at constant temperature, thus the change in internal energy delta U is equal to 0, because internal energy is depend on the temperature. When the temperature is constant, so there is no change in temperature, so there is no change in internal energy. Based on the first law of thermodynamic equation, heat energy Q is equal to the change in internal energy delta U plus work done W. So when delta U is equal to 0, heat energy Q is equal to the work done W. In isothermal changes, PV is constant. Equation PV is equal to constant can be expressed as P1 V1 is equal to P2 V2. If the gas expands isothermally, thus the final volume V2 is greater than the initial volume V1. So work done is positive sign. If the gas compressed isothermally, thus the final volume V2 is less than the initial volume V1. So work done is negative sign. This is the PV graph for isothermal process. If we look at the arrow of the process, volume 1, initial volume, is less than volume 2, final volume. So this is the expansion of isothermal process. (14.2a2) Isobaric or isovolumetric process. Isovolumetric process is defined as a process that occurs at constant volume. When the volume is constant, there is no area under the PV graph. Work done is equal to the area under the PV graph. So work done is equal to 0 for isovolumetric process. Based on the first law of thermodynamic equation, heat Q is equal to the change in internal energy delta U plus W. When W is equal to 0, so heat energy is equal to delta U is equal to the final internal energy U2 minus initial internal energy U1. In an isobaric process, all the energy added as heat remains in the system as an increase in the internal energy. Thus, the temperature of the system increases. For example, heating a gas in a closed constant volume container is an isobaric process. This is the PV graph of isobaric process. The volume is constant. If we look at the arrow of the process, the pressure is increases. Pressure at final state P2, final pressure, is greater than pressure at initial state P1. 14.2a3 Isobaric process. Isobaric process is defined as a process that occurs at constant pressure. Delta P is equals to 0. And the work done is W is equals to P pressure delta V, the change in volume. Based on the first law of thermodynamic equation, Q, heat, is equals to delta U, change internal energy, plus work done W. So Q is equals to delta U plus P delta V. For example, boiling water at constant pressure is an isobaric process. This is the PV graph for isobaric process. If we look at the arrow of the process, point 1 is the initial state, point 2 is the final state. The volume is increases. So this is the isobaric expansion. The volume, final volume V2 is greater than initial volume V1. (14.2a4) Adiabatic process. Adiabatic process is defined as a process that occurs without heat transfer into or out of the system. So Q, heat energy, is equal to 0. Thus, based on the first law of thermodynamic equation, Q is equal to delta U plus W. When heat is equal to 0, so delta U is equal to negative W. Is equals to final internal energy U2 minus initial internal energy U1. Delta U is equal to negative W for adiabatic process. For example, the compression stroke in an internal combustion engine is an approximately adiabatic process. In this process, there is no exchange of heat between the system and the surrounding. So delta Q is equal to 0. For adiabatic expansion, if we look at the arrow of the process, volume 2, final volume, is greater than initial volume V1. So work done is equal to positive value and delta U is negative value. Hence, the internal energy of the system decreases. The internal energy is depend on the temperature. T2, temperature at final state, is less than T1. For adiabatic compression, if we look at the arrow of the process, the initial volume V1 is greater than final volume V2. So the work done is negative value, but the change in internal energy delta U is positive value. Hence, the internal energy of the system increases. T1, temperature at initial state, is greater than temperature at final state T2. 14.2b This is the pressure volume PV diagram graph for thermodynamic process. There are 4 paths of the process. Path AB is the isothermal process, which is temperature at B is equal to the temperature at A. Path A to C is the adiabatic process. If we refer to the arrow of the process, temperature at C is less than temperature at A. Path A to D is Isobaric process. Temperature at D is less than temperature at A. Path A to E is the Isobaric process. Temperature at E is greater than temperature at A. There are 4 curves of temperature: T1, T2, T3 and T4. T4 is greater than T3, T3 is greater than T2 and T2 is greater than T1. Okay, thank you. Bye.